Good day, my dear STEM students. For today, we'll be discussing all about dilution. Okay, this is one way of mathematical way of expressing concentration. But before we proceed, okay, let us compare first what is the difference between concentrated solution and dilute solution. I have here this illustration of a concentrated and dilute solution. So in comparing the two, so concentrated solution has a lot of solute in a small amount of solvent. So greater ang amount ng solute niya than doon sa solvent niya. Okay, while in dilute solution, a small amount of solute in a large amount of solvent. So the solvent is much greater in a dilute solution. And then as you can see qualitatively, the color of the two chemicals, in the concentrated one, it's much darker compared to the dilute solution. Okay, so dilution is the process where the concentration of a solution is lowered by adding solvent to the solution without adding more solute. Okay, so before, ito yung itsura niya in this particular example. So before diluting, so this is the color. Qualitatively, you can observe that the color is much darker compared to the dilute one. Okay, so in most laboratory setting, a stock solution is created when a compound is used over and over. Usually, inside the chem laboratory, when we prepare solution, meron tayong natitira, and that particular solution, leftover, is what you call the stock solution. That particular stock solution has a specified concentration. Okay? Based dun sa paano natin siya ginamit. Kung halimbawa, ang kailangan lang natin is 2 molar, so nag-prepare tayo ng 2 molar, sumobra siya, so meron kayong 2 molar stock solution. This stock solution will have a high concentration. If lower concentrations are needed, a dilution is performed. So that's the time na para hindi masayang yung mga stock solutions natin, gagamitin nyo yung natirang yun by performing the dilution process. Okay, dilution is mathematically expressed as m sub 1 v sub 1 is equal to m sub 2 v sub 2. This is the mathematical expression for dilution. Doon sa previous slide, nakita nyo doon ang formulang ginamit is c sub 1 v sub 1 is equal to c sub 2 v sub 2. C stands for concentration. Okay, so same here, pinalitan, that is the old version of that formula, pero in some books, ginagamit pa rin. But in a newer edition of books, ito na yung ginagamit nilang formula. That is m sub 1 v sub 1 is equal to m sub 2 v sub 2, wherein m sub 1 is the concentration in terms of molarity. So these are the different meaning of the different variables in our equation. M sub 1 is the initial concentration in molarity. V sub 1 is the initial volume measured in milliliter, liter, and cubic centimeter. And then M sub 2 is the final concentration. V sub 2 is the final volume, also measured in milliliters, liter, and cubic centimeter. Okay, and then take note, M1 is always higher than M2 because M1 is more concentrated. V2 is always higher than V1 due to the addition of water as the solvent. Okay, so this is a helpful tool in verifying your final answer and it's in checking. Okay, you have to follow this condition when analyzing your final answer. Okay, let us have our first example. If you have 300 ml of a 1.5 molar sodium chloride, how many milliliter of 0.25 molar sodium chloride can you make? Okay, so in our given, okay, so let us analyze. Okay, so in analyzing dilution problem, laging merong dalawa dyan na pareho. So iti-take all nila yung condition. M sub 1 is greater than M sub 2, and then V sub 2 is greater than V sub 1. So tignan nyo na kagad yon. So in this particular problem, so ang pareho ng value or unit is the molarity, that is 1.5 and 0.25. So which is greater? This is 1.5. M1 is always higher than M2. So lagay nyo na kagad yung 1.5 sa initial concentration and then yung 0.25 dun sa final concentration, which is your M sub 2. And then analyze the problem. So how many ml can you make? Okay, so in the future yon can you make? So therefore, your unknown is the final volume. And then your initial volume will be 300 ml. Okay, so required is the final volume equation. M sub 1 is M sub 1, B sub 1 is equal to M sub 2, B sub 2. Okay, your unknown is B sub 2. So let us derive the formula. So B sub 2 is equal to, so simple lang naman yan pag nagde-derive ng formula, kung ano yung tabi ng unknown, siya yung ilalagay nyo sa denominator. So rewrite yung M sub 1, B sub 1 divided by M sub 2. Okay, so this is your final equation, and then substitute all given values. Okay, for your computation, B sub 2 is equal to 1.5 molar multiplied by 300 ml, that is your M1, and then B1 divided by M2, what is your M2, that is 0.25 molar, and then cancel the unit of molarity. Then follow the M-dash rule. You multiply first before you divide. And then 1.5 times 300, you will get 450 ml divided by 0.25. And then your final volume will be 1,800 ml. And then checking, let us analyze. M sub 1 is always higher than M sub 2. M sub 1, 1.5. M sub 2, 0.25. B sub 2 is always higher than B sub 1. Your B sub 2 is 1,800 ml. Your B sub 1 is 300 ml. So your answer is correct. Number 2, what will be the final molar concentration of a 25.5 ml molar sodium hydroxide aqueous solution when diluted to a volume of 100 ml? Okay, pag nakalagay dito, what will be? So, pag sinabing what will be in the future, so ibig sabihin, ang unknown ninyo is in the final condition. Okay, your M sub 1, okay, your M sub 1 is 5 molar sodium hydroxide. Your B sub 1 is 25.5 ml, and then your B sub 2 is 100 ml. V1 is always higher than V2. Okay, and then yung condition, what will be the final molar concentration? So, ang M2, ang inyong unknown, the final concentration. Okay, so let us derive the formula. So, M sub 2 is the unknown. It's equal to, kung ano tabi ng unknown, siya yung denominator. Okay, M sub 1, B sub 1 over M sub 2, and then substitute all given values. Okay, M sub 2 is 5 molar times 25.5 ml divided by your B sub 2, which is 100 ml. Cancel the unit of volume. Okay, then M dash 5 times 25.5, that is 127.5 molar divided by 100, you will get 1.28 molar. Okay, M1 is always higher than M2. Your M1 is 5 molar, your M2 is 1.28. So your answer is correct. Okay, how many milliliters of a 5 molar hydrochloric stock solution is needed to prepare a 100 ml 2.5 molar HCl solution? Okay, so compare natin. So ang pareho dyan is your molarity, so 5 and 2.5. Okay, so your 5 is your initial molarity, molar concentration, and your M2 is 2.5, and then your final volume is 100 ml. This time your initial volume is the unknown. Okay, so let us derive the formula. B sub 1 is equal to, so rewrite nyo yung magkatabi. So M sub 2, B sub 2, kung ano tabi ng unknown, siya yung denominator. Okay, which is M sub 1, and then substitute all given values. Okay, cancel the unit. You will get 2.5 times 100, you have 250 divided by 5. And then the initial volume is 50 ml. V2 is always higher than V1. V2 is 100 ml. Your V1 is 50 ml. Okay, if you have any question, just leave your question in our Google Classroom. Stay at home, stay healthy, and God bless everybody. Thank you.